Okay, so we've got PS10 is out due Monday, and then pretty soon I'll be putting PS11 up. And before Thanksgiving, remember you need to complete PS11A, which means you need to sign up as either a team of one or a team of two. So be sure to take care of that. I already have a PS11 discussion forum up, and you can use that if you wish to. If you want to advertise for a partner, you can do that there. And also, if someone reminds me at the break, I don't have to say anything, I'll try to say it again. If you'd like to talk to people, if you're interested in finding a partner, come down at the break, talk to each other, maybe you can find a partner that way. Do you have any questions or problems about anything before we go any further? Yeah?
So when you first open the GUI, should it automatically set a random tiles or do you want us to click a new game first?
Yeah, I'd say when you first open it, I guess it should just be all the lights off. Yeah?
On PS11, is there going to be more details about what you want
Oh, yeah.
for the project?
Oh, yeah.
And do you know when you're going to release those?
Later this week's my plan. Yeah, right now you go to the PS11 write-up, there's really no write-up. Let me get her first. Yeah.
When we enter manual setup, if the previous game is over, should it start a new game?
When you exit manual setup?
When you enter it, like if you just finished a game and
Yeah.
you haven't put a new game yet, you've already won, and you could enter manual setup, should it start a new game?
Well, no, you're not really playing a game when you're in manual setup mode. So, it should just, the screen shouldn't change, it should just be in manual setup mode, then you can change whatever squares you want to. And then,
For mine, when I do that and then I exit, because I've already won, whenever I try to do anything, it just shows you winning, because I've already won the game.
okay, and that's something you need, that's a thing you could deal with in your code. Yeah? Yeah?
So when the game opens up for PS10, you don't want any of the lights on?
I didn't really specify, so I'm not going to take all points for that. But,
So if you can open up the new game, can be started?
yeah, that'd be okay too. So I was talking about this assignment to Peter Jensen, who's a professor, he's teaching 2420 right now. So he went out and wrote a program to solve lights out, and he tells me that every position that can be solved in 15 moves. And about a quarter of, if you generate the positions at random, only about a quarter can be solved. So I thought that was interesting. Yeah? Okay, he's asking once you have a partner, how do you inform me? Well, you go to PS11A, which will lead you to this web page right here, where you enter your unit and your partner's unit and your team name. And click submit, and it sets you up in Canvas as a team. And that means this assignment you submit as a team. So if you have a partner, when it comes time to submit, only one of you needs to submit it. And it'll be graded once, but you both get the same grade. Yep.
Do both people fill this out? Or is, I guess I think using the both of their time? If I go to Project 11, I'll see this page, right? And then my partner will also see this page?
If you go to PS11A, there's a link to this page.
Yeah.
Yeah, you need to fill, one of you needs to fill this out. And what? Yeah.
What's the question? What was the question?
Oh, you want to know? The answer to the question was only one of you needs to fill out the form. And even if you're a team of one, you still need to fill out the form. Because you won't be able to submit if you don't belong to a team. All right, so just to show you where we're headed, and just because I'll show you what you'll be doing on the final project. So I'm going to give you a starting point. The starting point is really a very crappy version of the game. So this is the point. This is the thing you're aiming for. So when you run the game, you get this choice of classic versus enhanced. So this is, to be clear, this is PS11. The classic version is basically what the required elements you have to do. So it'll be a list of things the game is supposed to do, and you've got to implement that in the classic version. Then there's extra credit available. If you do extra credit, you implement the enhanced version and add extra stuff to it. Initially, if you try to do the enhanced version, it'll say, sorry, there is no enhanced version. You don't have to do an enhanced version. And this is the classic version. So this is Asteroids. And you start a game and you got a little ship here, and the ship can fly around. And I'm not very good at it. And you can also fire bullets. And when you hit an asteroid, it breaks up, and if you hit it enough times, it really bad. So I've gotten 170 points so far. And if you manage to play it up to 3 levels, then alien spaceships start showing up, and I got to settle down here. So, see, I never did master flying and shooting at the same time.
You did, you did.
Anyway, it's rumored that on levels 2 and 3, alien spaceships show up and start shooting at you. So anyway, the way this will work is I'll give you a starting point, which I'll show you the starting point here. Asteroid starting point.
You get the level 2 by wiping out all the
You
asteroids.
kill all the asteroids, you get to the next level.
Are all the sounds and stuff going to be provided?
I'll let Stefan play it. I want to test my code. What's the question here?
Are all the sound
Oh yeah.
waves supplied?
Yes. Yeah. I should have turned sound on when I was playing that, because that's part of the game. So in level 1, you only got 1 asteroid, and the ship will only turn right, and you can't control its speed, and you can't fire bullets. So basically, all you can do is run into the ship, run into the asteroid. So I'll give you the code for that, and then you need to go from there with it.
So, wait, so does the GUI come with it as well?
Yeah, what you see comes with it. The most important thing I'm giving you is, I give you, my implementation can tell when 2 objects are touching, have intersected, so that you know to blow them up. That's sort of some low-level code you don't have to write. Yeah.
So wait, you give us all the images as well?
I give you they're not images, they're just drawn with lines, with graphics lines.
Does it draw
So-
those randomly, or is it like,
What's what?
does it draw those asteroids like around?
No, I'll give you the code that draws the asteroids. So I'm going to turn the sound on here.
Yeah.
Oh. For some reason it's not playing the sound. I think it's because it's plugged into the HDMI cable and the room speakers aren't playing the sound for some reason. So anyway, that's a major part of the game. But I give you all the sound files. I need an example code on how to play the sounds. Okay. So this will come out toward tomorrow probably, and then we'll talk about it next Tuesday in lecture, and next Tuesday in lab, and also Wednesday in lecture for those of you that come. I realize 4 o'clock on the day before Thanksgiving, 3 o'clock the day before Thanksgiving is not. I expect attendance to be low, but it is live stream. Yeah.
So is the enhanced version just supposed to have more to the game, or is it supposed to look better?
No, the enhanced version just has more features. And we have a list of features that people have added in the past, so we sort of have a scale of points you can earn. But if you do something that's not on the list, we'll figure out some number of points to give you for it.
So you gave us the ship and the asteroids, or at least those drawings.
Mhm.
Do you have alien ships in there too, or is that like the extra credit where we?
No,
we would have
no, the alien ship's part of the required elements, but you'll have to
Okay.
draw them.
Okay.
All right, I just wanted to give you a little preview there. Okay, so we're going to continue talking about polymorphism. And first thing I want to show you is I'm going to look at the Mobile code that you did for an assignment. And in particular, I'm going to look at this file, mobile.java, which is how you represent mobiles. And I want to know if any of you have thought there was anything, I don't want to say strange or weird, but we could improve upon this way of representing mobiles. I wonder if any of you have any ideas how to improve the way of representing mobiles, which is basically every mobile has a instance variable that tells you whether or not it's a bob. If it's a bob, then that instance variable contains the weight, and if it's not a bob, then these instance variables here contain information about the rod. So, how could we do better? Okay, I'll ask a related question. I imagine, I haven't looked at everyone's solution, every program they've written since we started working on classes, but I do know that some students get into the bad habit of every time they want to declare a variable, a local variable like I, or total or something, rather than declare it inside the method where it belongs, they declare it as an instance variable. I think just maybe it's just convenient to put all the variables up there. Why is that a bad idea? Why is it a bad idea to declare local variables as instance variables? Maybe one of you can answer.
I mean, if you're, it becomes harder to do things with it, just because, like, if you want to use the same variable in multiple places at the same time,
Okay.
it causes complications.
Okay, so to paraphrase, suppose we have two methods that both have a local variable I, and instead of declaring them there, you just declare them as an instance variable I. And both these methods use that variable. Well, if this variable is looping through, this method is looping through I, and it calls this method, which also loops through I, suddenly they're interfering with each other. So that's the main reason why it's a really bad idea to have instance variables that really should be local. But there's another reason it's a bad idea. Yeah?
I just had a question about
Yep.
that. I remember putting them as instance variables because I couldn't figure out a way to initialize it or declare it as like 0, like to start out. Then when it recurred, it still made it 0 again to going through it. And I couldn't figure out how to keep the number that it was at. So when it was like trying to accumulate, it would go back to 0.
Okay, but if you have a local variable inside of a method, and it's recursive, every time you make the recursive call, that call gets its own copy of the variable. It's not going to bother, if this method calls this one recursively, local variables here are not affected by this one down here. So maybe I should look at what you did, and I could probably give a better answer. Yeah?
Maybe because the variable is specifically for some method, but if you declare it as an instance variable, whenever you create an object, you're going to use this variable, but this variable is specific for some method. You don't necessarily use it.
All right, so what he said is sort of halfway to where I want to get. What he's saying is that variables that are specific to a method don't belong in the object because then they're accessible to all the other methods. Now, I'll ask you another question. How big is an object? How much space does it take to store an object in memory? Yeah?
Does it depend on the size of the object?
Well, it depends on the size of the object, yeah, but what determines the size of the object? Yeah?
The amount of variables and functions inside of that object?
Okay, it doesn't depend on the functions. It just depends on the instance variables. Okay? Every object contains space to store each instance variable. It also contains a reference to the class of the object, and that's how you get at the methods. The class contains the methods. The object contains a reference to the class. So when a method is called on an object, you go follow the reference and find the method that way. But there's space for every instance variable. So if you're storing local variables in the object, your objects are bigger than they need to be. And if you only ever create one object of a given type, that doesn't really matter. But if you're creating millions of them, that's a lot of memory wasted. So then we go back to this. How could we improve the memory footprint of a mobile? Why is it kind of wasteful? Yeah?
Well, on any given mobile, it only needs some of the instance variables we have. I guess in the spirit of polymorphism and the implementing of interfaces, I guess it might be more efficient to say we have some kind of mobile interface, and then there's maybe a Bob object and a larger mobile object that.
Okay. So what he said pretty much nails it. A Bob object only needs to know a weight. It doesn't need to have, it doesn't even look at left length, right length, left and right. That's just dead memory. And similarly, a rod object, it doesn't need to be storing a weight. It just needs to store the last four instance variables. So our strategy is going to be, rather than have a single mobile object, we're going to make a rod object, and we're going to make a mobile object, I mean a Bob object and a rod object, and see if we can get them to cooperate. Yeah?
So under the current organization, like with all those instance variables, even if you just make a Bob, it still has...
Yes, it still has all those instances, room for all those variables. Okay. Right, so it's taking a lot of space to store Bob. All right, so let me show you what I have in mind, how polymorphism comes into it. So Mobiles 1 up here is the version in the solution. This is mobile examples we're going to look at. And this is how I want to be able to create mobiles. So, actually, it'd be better if I compared it. So let me go back here. Here's the original mobile examples. So our original strategy is, when we're going to create a mobile, you can see we're creating like the first line that starts M6 equals. Well, we're creating a Bob by calling the one argument constructor for mobile. That creates a Bob object. Then we create another Bob, and then we compose them into a rod. So we have, the mobile class provides two constructors. One when you want to create a Bob, one when you want to create a rod. I would like to move to this strategy, where we have a class called Bob, and it has a constructor that takes in a weight. And we have a class called Rod, and it takes in two integers, or two doubles, I guess, and two mobiles, which could be rods or bobs, and makes a rod out of them. And I want both rods and bobs to count as mobiles. So how are we going to do that? It's clear enough we could create a class called mobile, and a class called Bob, and a class called Rod. But how can we arrange for both of them, for Bob objects and Rod objects, to also be treatable as mobiles? Yes? Behind.
I was going to say that in your classes where you're defining rods and bobs, have them extend mobile.
Okay, so he said we could create a mobile class and extend it. All right, so we could have Bob inherit from mobile, and we could have Rod inherit from mobile. That's one way. There's another way I'm going to do it, though. Yeah?
I think someone already mentioned you could create a mobile interface.
Right.
And then you implement that.
So what I'm going to do is create a mobile interface and have both Rod and Bob implement that interface. So let's see how we can do that. So I'm going to go back over here. I'm going to change mobiles to here. So I'm going to take mobile.java and I'm going to copy it. And then I'm going to paste it back in. And I'm going to call it, I'll call that class Bob. And I'm going to paste it in again and call it Rod. And then we're going to have to do some rearranging to get this to work. All right, so I've got a Bob class and a Rod class and a mobile class. And currently they're identical. So here in the mobile class, I want this to no longer be a class. I want it to be an interface. So what should the interface contain? Yeah?
Method stubs.
Method stubs of the methods that Bob and Rod have in common. So what are those stubs? It's like heaviest Bob, for example. So we want anything that claims to be a mobile had better provide a heaviest Bob class. Okay? It had better provide a longest rod class. It had better provide a rod count class. It had better provide a bob count class. I should say method. And so on. So I'm just turning all these methods into stubs. We need as balanced. We need weight. We need this one here, which is display, or it won't be able to display itself. So I need a display method. Okay? Now, these constants have to do with formatting. We've got to put them somewhere. I'm just going to leave them in the interface. So that's another thing you put in the interface, are constants. Now, what about this constructor here? Do we need a constructor in the interface?
No.
No, you can't have a constructor in the interface. Because you cannot directly, you'll never say new mobile anymore. If you want to create a mobile, you either got to create a new rod or a new bob, because those classes implement the interface. So we'll get rid of that constructor. We'll get rid of this constructor. What about the instance variables? No, can't have instance variables, don't need them, because we're not implementing the methods. Okay, so there we have our interface. So it says if you want to claim to be a mobile, you must provide these methods: display, weight, is balance, and so on. Simple enough. Let me pause here and see if there are any questions. Yeah?
What about the public final static variables you have in there?
Yeah, we're gonna leave the constants in there. I got no better place to put them, and they can go in an interface. So that way they'll be accessible to any class that extends the interface.
So, why use why use an interface instead of an abstract class?
He's asking, why use an interface instead of an abstract class? I'm not ready to answer that yet, because I haven't really talked about abstract classes. But just since you asked the question, I'll just tell you. Basically, an interface is a lot like an abstract class in which all the methods are abstract. But I'll just leave it at that. Other questions? Okay, so remember, we're doing this so that we'll be able to treat a rod as a mobile. So a rod object can be looked at as a rod or as a mobile, and the same thing for bob. So we're going to have to go into let's do into the bob class and see what we need to change. So first of all, we need to say that implements, we need to add that. We need to add that we're implementing the mobile interface. And that's what lets us use a bob anywhere a mobile is required. Okay? And similarly, in mobile, we need to say implements, not mobile. Sorry. In rod, we need to say implements mobile. Okay? So now, mobiles, rods are kind of mobile, bobs are kind of mobile. Let's go in here and see what errors there are. No. I'll come back to that in a minute. Okay, here we are in bob. What do we need to change about the bob class now? Yeah?
Well, some of the methods are kind of redundant because we could reduce a lot of them just down to the base case, and we don't need recursive.
Okay. Okay. So there's code in here that deals with both bobs and rods. We just need the bob code. So do we need an is bob instance variable? No, a bob. If it's a bob object, it's a bob. Right? We don't have to ask, are you one or the other anymore? So we don't need that. Do we need to keep track of the weight of a bob? Yes. Absolutely. But we don't need to keep track of this other stuff, because this stuff's only interesting if you're talking about a rod, which we aren't. Okay? So here's a constructor that creates a new bob. What I'm going to do is, I don't have the is bob anymore, so I'm just going to record its weight. Okay? Okay? We don't need this constructor because that was for rods. So we'll cut that out. What about these constants? They're declared in the interface, so we don't need those either. Okay, now here's the display method. Someone says to a Bob, display yourself. What should it do?
You should just do that if it is on.
It should just do this stuff right here. It doesn't need to ask, am I a Bob? We know, if this method is called, we know it's a Bob. So we're just going to run the code that's specific to Bob, and this stuff here is only specific to Rod, so I'll cut it out too. Let's see if I got it looking good. So there's our display method. It's just Bob specific. What about weight here? What's the weight of a Bob?
Just return weight.
It's just, you return the value of the instance variable. So we can take that out, take out the Rod code, and we're left with a very simple one-line method. How do you tell if a Bob is balanced?
It is.
It just is. So all we're doing is we're just taking out, we're just leaving behind what you did if it was a Bob. So I'll take this out and take that out. Bob count, you always return 1. Rod count, you always return 0. So suddenly, the code's looking a little bit simpler. There's never a decision to make. Someone asks you, what's the longest rod in a Bob? You say 0, because there isn't a rod.
Do you need it?
Hmm?
Do you need it?
Do I need what?
Do you need that method?
Do I need this method? Fair question. What's this method there for? I mean, do I need that method?
Yes.
Why?
Extending mobile, so we have to.
Right, we're implementing the mobile interface.
If you leave it blank, it's still.
No, it has to be implemented. We can't leave it blank, because that won't compile. It's supposed to return an int. The interface says there has to be a longest rod method.
When we're using the mouse press and mouse click, that was an interface, right?
That was another example of an interface, yeah.
And on some of those we didn't.
Right, because they were void methods. They returned void, so there was no need that you could leave them empty. But yeah, this has to do, it has to do what it says. It's supposed to return the length of the longest rod contained in this mobile. We can change the comment. If there are no rods, return 0. A Bob contains no rods. This one here, okay, and we're done. Now we have a Bob class that provides very simple implementations that are specific to Bobs. And we didn't come here and simplify the comment. A Bob is a mobile that, I guess I should say, consists of this. So I'll take all this stuff out. Okay, there we go. Even clean this up here. We don't need this transform. Okay, so now we have a Bob class that implements the mobile interface. Yeah?
On the last one, the heaviest Bob, did you just return weight? Is that what you were
Yeah.
saying? Why does that work?
Well,
For just a Bob.
yeah, if a mobile consists of a single Bob, the heaviest Bob in it has to be that Bob. All right, all I did was take the base case out of all the ifs. Now, what happens with rod.jump? How are we going to, what do we have to do with it? Right? We don't need this stuff anymore. This is just sort of the opposite of what we did before. So we'll take out the stuff that's specific to Bobs. We'll leave in left length, left, and right. We don't need this old constructor, but we do need this one. The formatting constants we're getting from the other class. And now we can go through and get rid of everything specific to Bobs. So I'll do that and leave behind this. Down here with weight, we just need this part. Down here, we just need the code for rods. Depth. rod. And heaviest bob. Okay, and I guess I could come up and clean up the comment at the top. I don't need the bob part. And we're done. So we have split bob and rod into separate classes to implement the same interface. Why is the interface necessary? Yeah?
So that you can still treat them both as mobiles?
Okay, we can treat both kind of objects as mobiles, but the reason that's a good idea, look at this constructor. What happens when you construct a rod? What can you pass as the third and fourth parameters?
Mobiles.
Left and right. Right. Left and right can be mobiles, which means either a bob object or a rod object. What if we change this from, oh, I see the problem. I assume that said something different. What's the problem with this constructor? Giving away the answer. Yeah? Right. This says that a rod consists of, two submobiles which are both rods. So there's no way to ever put a bob hanging as part of a rod. So what do we need to change where it says rod? What do we have to change it to?
Mobile.
Mobile, so that you can pass in either a rod or a bob. And this should be declared as mobile, and this is mobile. When I rename the classes, it automatically changed those names. Okay? So that means that a rod contains two mobiles, which will either be a rod object or a bob object. The way it was declared before, they would have to be rods, and you wouldn't be able to construct mobiles that way. You never put a bob in. Okay? Now look, this class here, mobile examples, is now happy. Didn't want to open. This is the one here. Okay? So look at how we're constructing. Look at that first line. We construct a bob of weight 10 and a bob of weight 40 and pass those into the constructor for the rod. And it makes a mobile out of them and stores it in variable M6. Why is it okay to store that rod into a mobile variable? Yeah?
Because they both implement mobile. So
Right. They both implement mobile, so we can do that. We could do this if we wanted to. You could declare it as a rod. It won't hurt anything. You couldn't declare it as a bob, though, because it's not a bob. Okay, now let's go see if our code runs. So here is Mobile Viewer. Let's run it. The right thing. Here's the main method. Oh, it's in here. Okay, so it's still working like it did before. But I want you to tell me something. Let's go to rod.java here. Let's suppose someone calls the wait method. So we have a rod, and we want to know its weight, so we call the wait method. And we compute that by adding the weight of the left. We invoke weight on the left mobile and weight on the right mobile that make up this rod and add them together. What method is called? What method is called when we call weight on the left mobile, or equivalently on the right mobile? Yeah?
It depends on whether it's a bob or a rod.
Okay, he says it depends on whether left is a bob or a rod. Okay? Does anyone have a different answer? Yeah?
returns the mobile method because that's the left
Well,
mobile and the right side.
Well, he says it uses the mobile weight method, but there is no mobile weight method. Remember, mobile is just an interface. Okay? Anyone have a different answer? I don't know, it sure looks like that when we call weight, Shouldn't it just be calling wait? It's just recursive, right? Does anyone want to make, does that make sense? Yeah?
Until it reaches a bob, then it'll call the bob.
Okay, so you're saying until he reaches a bob. I'm not getting anyone to go out on a limb and say that when we call left.wait, it's going to call this method right there. Okay, and that's good because that's not the right answer. Yeah? Because the rods don't what?
Because the rods don't weigh anything, it's the bobs that weigh it.
Well, so here's the thing. Let's go look at this picture again. Suppose we ask for the weight of the top level mobile there. So what we do is we recursively compute the weight of the left mobile and the weight of the right mobile and add them together. Now, when we call and ask for the weight of the left mobile, when we say left.weight, what Java does is it looks at that object, left. And if that object is a rod, it calls the weight method from the rod class. If that object is a bob, it calls the weight method in the bob class. This is determined dynamically when the program runs. So you can't look at the code and say, when I call left.weight, it calls. It's wrong to say that it calls the rod weight method, and it's wrong to say that it calls the bob weight method. It calls one or the other depending on what left is. Okay? That's the way inheritance and implementing interfaces work. The method is called dynamic method dispatch. The exact method that's called depends on the object you're calling it on. So let's go back in here. Let's suppose in Mobile, let's add a new method here. Public void foo. Okay? Could we call foo from inside of wait if we wanted to?
Yeah.
Right, we could call foo. Okay? That's an abbreviation for this dot foo. Okay, so we're calling foo on the method, the object that wait was invoked on. Can we do left.foo? What is it? Yes or no? When I write a T, is there going to be an error marked or not? All right, you can. And it says, that's what I said was you can't. And the error message is, the method foo is undefined for the type mobile. So the thing is, sometimes left will be a bob, sometimes left will be a rod. And so Java's not going to let you try to call foo because that won't work all the time. It'll only work in the cases when left is actually known to be when left is actually a rod. And Java has no way to tell in advance which is going to be. So the method you're allowed to call is enforced by the compiler. So when we're trying to decide what can you do with the left object, you can only invoke methods on that left object that are named in the mobile interface. But then which of several methods is actually called is determined by the type of the object. Yeah.
So even if we define foo for a bob, this still won't work.
Even if we define foo in the bob class, this still wouldn't work. What would it take to make it work?
Put in mobile.
We have to put foo in the interface. Yeah.
Let's say we wanted to go off, but only when it's in this class, when left or right is a wrong. How would one go about it?
Well, we'll talk about this later. There is a way of testing the type of something. You can say if left is in fact, so the operator is called instance of. So if left is an instance of a rod, so that'll be true if left actually is a rod object. Then what you can do is you can cast it. You can cast left. That says right there, treat left like it's a rod, because it is. It says it's safe to do so because we checked. Then you could call foo on it. So this cast right here is saying, let's stop viewing left as a mobile. Let's start viewing it as a rod. Then you can call the foo method. If on the other hand left happens to be a bob, then this if won't run. The body won't run. But that's an idea for another time. Yeah.
Just out of curiosity, if you cast it without the if statement, will Java still compile it?
Yep. So you can do it this way. It'll still compile it, but what might result is a runtime exception. Now, Java won't let you do this. Okay? Why is it not letting you do that? So we're trying to cast left to a string. Why is the compiler saying no way? Yeah?
Is left isn't a string?
There's no way left could be a string, right? Left has to implement that interface, and string doesn't implement that mobile interface. It knows, the compiler knows this is doomed to fail, so it doesn't even let you try. So if I hover the mouse, it's going to say, cannot cast from mobile to string. It's just no way. Yeah?
Why wouldn't it just use the default to string method?
The default, well, it's not, we're not asking it to construct a string here. We're saying, what you're saying when you do this is, you know, I think left is actually a string. Start treating it as such. But the compiler knows it's not a string. And even if it were a string, you wouldn't run foo on it. So I guess I should say, like, run an actual string method. Right? But it just, rather than let you try and have a guaranteed exception, it's just telling you in advance. There's no way that can possibly succeed. This object cannot be a string. So you're only allowed to cast to think when it might succeed. So this idea of dynamic dispatch, that the actual method that's called is determined by what type of object that is really key to what we're studying here. And that's determined at runtime. Sometimes this will be a rod, sometimes it'll be a bob. Now, it would be bad news if this always called the wait. If this wait always called that one, we'd never hit a base case. We'd have infinite recursion, and eventually it would fail because we wouldn't be calling wait on something that's a rod. Okay, so and I should add, doing the final assignment, doing asteroids, requires doing lots of implementing interfaces and extending classes, doing interfaces and inheritance. That's sort of key, central to the asteroid framework I'm going to give you. So this is sort of the last major thing. This is the last major thing I'm asking you to understand. But it's, you know, we'll still be worrying about it in the next 3 weeks. So if you have any questions, now's a good time to ask them. Yeah?
On all the methods that you implemented in the rods and the bobs, you didn't do the override override, but you don't need to, right?
It didn't do the what?
You didn't use that at override in just the...
Oh, yeah. So I think this code predates that option being in Java. So that's why it's not there.
But is it good practice?
It's good practice, yeah.
Well, if you misspell something, even in the case of an interface, it will give you that.
Right. So if I do this, you know, like, or if I don't even misspell, let's say I add a parameter here, it's going to tell you there's no such method in the interface.
And that'll be done with or without the override.
Yeah. No. You only get the warning if you do the override. That's the,
even on interfaces.
Okay. Yeah. So if I do this, there are going to be other errors here because of this recursive call here. But if I take out the override, I guess there are no other errors. It's just basically saying, okay, there's a new method called wait. This method does not override anything. You might think it does. And so the advantage of the override annotation is you're asking the compiler to check, am I overriding like I think I am? And you do get the warning here. So it's good practice, and I should have added in here. Oh, I guess it's not in there because I just wrote the code while you were watching. I just didn't add it in. Yeah?
Is there something we can do with the full method, and we check it in full method, and the left.wait works in the method below?
All right, say that again. So we got left.wait and right.wait.
Yes. So, but if we write left.wait itself, it doesn't work. It's not compiled. And so, I mean, if we check inside the full method, and if it's Bob or Rob, and throw an exception, and can we run in the below method left.wait or right.wait?
Below method, you mean this one?
No, this is full. Oh, sorry. upper weight method.
Okay, I'm not sure what it is you're, okay, so give me an example of what it is I can't do.
So, so we have a method flow, and we check. I mean, is there any way we can, do inside the flow and to let it works in the weight method and the left dot weight or right dot weight?
Yeah, you can call left dot weight from in there. Because this is just a method of the rod class, so it has access to the instance variable left. Maybe I can talk to you at the break. Any other questions? Right. The next thing we're going to look at is a different example that makes use of inheritance, among other things. We'll take a break and do that.
Yeah.
All right, let's get started again. Okay. Next example. So what I've got is really a series of examples. And it's leading up to this program here. So I'm going to run this program and show you what our goal is. So it's a little application. Up here at the top, if you can't see in the room here, is it says oval, rect for rectangle or line, and then red, green, or blue. So right now they work. I mean, you can click on them, but they don't do anything. Oh, I'm sorry, they do work. This is the demo. So if I want to draw a red oval, I set it to oval and red, and then I push down the mouse and drag it, and it creates an oval. And if I want to create like a green rectangle, same sort of thing, a blue line, same sort of thing. I can draw a sequence of lines just by clicking the mouse each time. Anyway, so you can create, it's basically a really stripped down paint program. So you've got 3 colors and 3 shapes that you can use. And, you know, I'm not so interested in writing paint programs. What I'm interested in is showing you the polymorphism that went into making this work. So, so I'm going to X out of this, and we're going to start. I've got a series of programs, Paint 1 through Paint 7, that gradually implement what I just showed you. So I doubt we'll finish today, but we'll see how far we get. So let's start with paint.java, and let's see what it does. So this is rather paint1.java. So I run paint 1, and this is what it does. It draws a blue rectangle. So there's no, you can't do anything with the mouse, and none of this matters up here. So this just exists to show you how to do the graphics, basically. So let's see how the graphics are done. Now, the way this program is structured, paint.java takes care of the window, you know, the JFrame that makes up the window. It lays out those 2 controls up there, those 2 sets of radio buttons. It creates that file menu, and then we can use the file menu to quit, close. And there's a class called Paint Panel that it adds to this thing here is a Paint Panel object. So, you know, these programs differ, but they all use the same top-level class. The Paint class is the same. They only differ in the Paint Panel classes. So we won't look at I'm not interested in the Paint class, I'm interested in the Paint Panel class. So let me close that, and we'll look at Paint Panel and see what's up. So first thing you see is here's an example of we're using inheritance. So what's the deal? Why do we have Paint Panel extending JPanel? Yeah?
We want its methods. We want to be able to do stuff too.
Okay, so we say we want its methods, meaning JPanel's methods. So we want an object that behaves like a JPanel. You know, we want to be able to, among other things, add it to the frame. You know, add it so it's displayed. But then, we don't just want a plain JPanel. We want to customize it. What is it about this thing that we need to customize going forward? Why won't a plain old JPanel not work? Yeah?
We need to be able to draw on it.
Right, we need to be able to draw on it. So we're going to have to override some of the mouse listener methods to tell when I'm clicking and dragging. And we've also got to customize what happens when the panel is displayed. By default, when an empty panel is displayed, all Java does is it draws a background in some color, whatever the default background color is. And we've got to make it so that it actually draws something. So we say, okay, I want a paint panel. It's just like a JPanel, but here's some differences. Right? One difference is it has an instance variable called paintFrame. So it has a reference back to the object that contains it. It has a constructor that you find out from the constructor, you get the group of 3 shape buttons, the group of 3 color buttons, and the paintFrame. Right now we're ignoring the buttons. We set the background to white. We remember the top level frame. Okay? What's happening here? This method here, paint component. Yep. Okay, so he's focusing in on this. But let's focus first on this bit. What does that tell you? What's going on here?
There's like a paint component that belongs to the JPanel.
Right, so JPanel, the fact that we're overriding it tells you that paint component is a method from the JPanel class. Takes care of painting the JPanel. We're overriding it. We don't just want to have a panel with a white background. We want to have an oval on it. So we're customizing what happens when paint component is called. Now we're not ever calling paint component. That's done, other swing classes decide when to call paint component. So like if the window is covered up and suddenly it's uncovered, it'll call paint component to bring it up to date. So, but we're basically, it's like taking a car and, some people buy a new Jeep, and the first thing they do is they throw away the wheels, and they put bigger wheels on it and get it lifted so it's higher and goes over bigger things. So they're taking a car and changing it, and we're just taking a part and changing it here. We're just putting in a new part, and fortunately it's easy to do. By doing this, instead of the old paint component method being called, this new one will be. And then we turn around and do this. So super is a keyword that refers to the superclass, the class that we're extending. So super.paintComponent, we're saying, okay, I know we're overriding the paint component method, but I still want to call the old one that's been overridden. So super.paintComponent calls the original paint method, the original paint component method for the JFrame class. And what will it do? Yeah?
It'll do that whole method from the super class, and then it'll do it added onto it.
Right. So it does whatever it used to do, and what it used to do is color the background. In our case, we're calling it white. So when we run the program, we get a white background. Now let's comment this out so that we don't do that. And that's, I don't know if you can tell, I think it's a different color, isn't it? Sort of grayish. And now it's a brighter white. So if you don't believe me, you can try this later. Just go change, we'll set the background color to white up above, set it to blue or something, and it'll be a lot more dramatic. So we're not so much replacing the old paint component as modifying it. So the new paint component method does everything the original did because we're making that call. And then, in addition, it does this stuff. Okay? So when I run it, I get the blue oval. And if I made this green, we'd get a green oval. Okay. I'll put it back. So all I'm doing, you notice the paint component method takes a graphics object as a parameter. And all I'm doing with it is calling Vermeer methods. I'm calling the set color method and the draw oval method. And that just draws on the component. And then I didn't realize I was doing that. Somewhere I'm saying oval, so let's run it and see. Down here at the bottom it says shape drawn oval. So that's where that's coming in. I guess there's a set legend method in here somewhere. Okay, so that's our sort of our base, our first attempt at this. Let's go back and make sure we understand where polymorphism is being used. So who could remind us? All the places. Tell me one place where we're exploiting inheritance or interfaces. Yeah?
We had paint panel X and JFrame.
Okay, right here. We're saying, okay, we want a new part. There's no part available that behaves exactly like we want. JPanel comes close, so we extend JPanel. We call it paint panel. And then we make some modifications. Okay? Where's another place we're using? Yeah?
The call, the super call.
Okay?
Super paint component.
That's right there, but before we get to it, right here, we are overriding the behavior of the paint component method. We're putting in a new paint component method. Same way you might put a new engine into a car. And then you don't have to call the original paint component. You can just leave it out and it's never called. But it does something useful. So we call it, and then we do some extra stuff as well. Okay? Yeah?
Is set legend something that's like a JFrame, or is that when you're...
Yeah, let's go find. So then there's a set legend method. And we'll go look at the declaration. Oh, that's back up in the, it's up in the other class we haven't looked at. So we have a reference to that paint frame. Remember that was passed to the constructor here. So we're calling the method on it. Yeah?
If you override a method and then you never call it again, is there like not really that? The method that you wrote originally just is never used?
You mean the one you overrode?
Yeah.
Well, in this object, right. And so if we commented this out, then the original paint component will never be called from a paint panel object. It'll certainly be called from other, you can create a JPanel object that's not a paint panel object. It'll be used there. Okay? All right. Good. Now let's look and see what features are in Paint 2. So I'm going to, here's the main. This is the same as before, just as a different class name. Let's see if I remember what this one does. So it displays a red oval. And if I change this to green, if I could force it to repaint, I believe it would draw a green oval now. How can I force it to repaint itself? What would coerce Java into calling the paint?
Call the paint component method or paint whatever, whenever you click that button.
Well, no, what I mean is, this is this program. How can I, by manipulating this window, force it to repaint? Yeah?
There's a refresh method?
No, there's no refresh method.
Repaint method?
I can't call any methods. All I can do is manipulate this interface here. I can drag the window around. Look, if I iconify it, and it won't show it to me, and bring it back up, now it's a green. So all we can do is trick Java into repainting the window for us, right? So if I say I want a red rectangle, okay. I'm surprised that didn't work. I guess it's buffering it, so that's not working. So the best I can do is iconify it and bring it back up. Okay? So what do you suppose I had to change about the class to make this work? Let's go back and look at so the original one was paint panel right here. This original paint panel. Come up. What do I have to change about this overridden method to get the behavior you're seeing? Yeah.
Could you add an action listener?
No, I didn't add an action listener. It's just, what you're seeing is that when you iconify something and then bring it back up, Swing has to paint, repaint all the windows that it's created. And that's what causes paint component to be called. But what do I have to change about paint panel so that if I change the settings and then calls paint component to be called, it displays a different color and different shape? What would I have to change in this method we're looking at so that it doesn't always paint a blue oval? Yeah?
Would you change something in Paint?
No, not changing anything in paint. All I had to change was paint component. Yeah?
Something with the button?
Right. Basically, paint component will have to look at the state of the buttons to decide what to draw. So let's go see what changed. I gotta make sure I'm in the right place. They all have similar names. All right, here's paint panel. So let's see. So now I have instance variables that keep track of the shape buttons, the 3 shape radio buttons, and the 3 color buttons. And they're passed to the constructor, and it keeps track of them. And here is paint component. So it calls, as before, super.paint component. And then what's happening here? So interpret this code for me. What does paint component do? What do you suppose this is doing? Yeah? Okay, I couldn't hear that. A little louder.
You're selecting the color as chosen.
Right. So I'm telling the graphics object, use this color right here. Well, that's a method I wrote, so let's go see what getColor does. Okay? It just looks at the color buttons. So this, the details aren't important here. It just figures out whether the red button is clicked, the blue button is clicked, or the green button is, I should say, selected. So there's 3 radio buttons. One of them is picked. Only one can be picked. And it returns either red, blue, or green, depending on which one is picked. And if none of them happen to be picked, it returns black. That can't happen, though. So it just looks at those 3 things at the top. So if I run the program again, it can tell which of these 3 things has been picked. And it returns a color object, and that's used to set the color of the graphics object. Then we look and see which of the 3 shape buttons has been selected. If it's oval, we draw an oval. If the rect button is picked, we draw the rectangle, otherwise we draw a line. So we just changed this method here, this paint component method, so that it looks around and figures out which shape to draw and what color to make it, instead of just always drawing a green or a blue oval like it did before. Okay? Make sense? I don't want to be mysterious here. There was no new use of polymorphism here. We just are using, I'm using some bits of the API that I've never shown you before, but that's not my main focus. The idea is that we can customize what happens whenever the window is painted. Okay, let's see what's new in Paint 3. So when I click, it draws an oval. In this case, it looks like a circle. Now it'll draw as many as it wants. I can change to rectangle and green, and it'll... So it's not letting me drag and choose how big these things are, but it is letting me pick a color and a shape and putting it there. Now, are they there permanently, or do you suppose if I iconify and brought it back, they would have disappeared? Let's see. Yeah. So they're still there. So what changes to the paint component method are going to be required now? Or to more generally to the class? Yeah?
We're going to have, we need a mouse listener for the dragging thing to work.
You need what?
A mouse listener.
Okay, we're going to have a mouse listener because it has to tell when I click somewhere. That's when it knows to place. So what will the mouse listener do when I click somewhere? Yeah?
Draw whatever it is, like shape you've selected with like the origin being when you click.
Okay, so he says I'm going to have to draw something. That's not quite right. It turns out that those methods won't draw anything, but it's a reasonable assumption. Can you envision the need for any new instance variables? Yep. Okay. He said we need some sort of array list of shapes. We need to keep track of which shapes have been drawn so that every time paint component is called, it needs to display all those old shapes. So the reason the mouse listener doesn't draw a shape, if the mouse listener draws the shape, if we iconify and bring the window back up, the shape will be gone. If the only thing that ever does any drawing is the mouse listener. So what will the mouse listener do? Yeah?
Returns like an X and a Y coordinate.
Well, it'll get an X and a Y coordinate. What will it do with it? Yeah?
It will add a new shape to the array.
Right, it'll add a new shape to the list so that when the list is repainted, that shape will be drawn. So let's go see what it took to do this. So now we're in Paint 3 package. So look what I've added here. I have an array list of ovals, an array list of rectangles, and an array list of lines. So I've got 3 array lists. One that contains all the ovals that need to be displayed every time the window is repainted. One that contains all the rectangles, and one that contains all the lines. Initially, they're empty. Okay, so the constructor makes them all empty. Now, what's happening here? And here, I should say, as well. This is polymorphism in action. What's happening here? What does it mean to say, add mouse listener this and add mouse motion listener this? Yeah?
You're adding a mouse listener and mouse motion listener to the paint panel you create.
Okay. So essentially what he's saying is, these methods belong to the paint panel class because they were inherited from the superclass. And what you can do, you can pass to a mouse listener, to add mouse listener, you can pass a mouse listener object. And that object is notified when certain mouse events happen on this panel. And similarly, you can give it a mouse motion listener. You can give it a add mouse motion listener takes as parameter a mouse motion listener object, and it's called when the mouse moves over the paint. So why can we pass this as a parameter to add mouse listener and this as a parameter to add mouse motion listener? Why does that work? Yeah.
Could it be like an if statement for if you just click and then an else statement for if the mouse is moving?
No, it's not. It's not. There's no if or else involved. Why is it okay to pass a paint panel object to a method that expects a mouse listener object? Yeah?
Because a paint panel object is a mouse.
Because a paint panel object is a mouse listener and it is a mouse motion listener. We implemented those 2 interfaces up there. Okay? Now, what did it take to implement those interfaces? Yeah?
You have to override the default.
We had to go down here. We had to implement all these methods. Mouse clicked, mouse entered, mouse exited, mouse pressed, which is the one I cared about. Mouse released, mouse dragged, mouse moved. So really the only one I care about currently, I'll eventually care about more of them, is the mouse pressed method. So I implemented those 2 interfaces. So what that means is that when someone presses the mouse button, when the mouse is over my paint panel, this method right here will be called. Right? Well, what does this method do? Look at that code and see if you can tell me what it does. Yeah?
So if you click like an oval, for example, you're gonna draw an.
There's no drawing.
Well, not you don't draw, but so you create a new oval object and you get the X and the Y and the color associated.
Okay.
With that.
So what it does is the mouse has been pressed, and so this code says, okay, let me look and see which of the shape buttons is currently selected. Am I supposed to be drawing an oval, a rectangle, or a line? And it figures it out. Let's say it's supposed to be drawing an oval. So it creates an oval object. An oval object will contain the x-coordinate of, I think it's the center of the oval, the y-coordinate of the center of the oval, and it gets the current color that's selected, and that's the color of the oval. So it creates a new oval, adds it to the list of ovals. Now, if it's supposed to be drawing a rectangle, it would do the same thing for rectangle and for line. So it just creates an object, writes it into the array list for that type of object. Right? It's just remembering, okay, next time you repaint, you better draw this new thing. And then, after it's done with that, it calls the repaint method, which is a method we inherited. What do you suppose repaint does? It's not hard to guess.
Sounds like a refresh.
Yeah?
Would it just repaint what you've already painted already, and it would just add whatever?
Right. It tells Swing, okay, go ahead and do a repaint, even if you didn't want to. Now, let's see what happens if we comment out that repaint. So I'll run the method, run the program. All right, I'm putting down a red oval, and I'm going to put down a green rectangle, and I'm going to put down a blue line. Now, why are we not seeing anything? It hasn't occurred to Java to call paint component. Now, what will happen if I iconify this and bring it back up? That will force the repaint, and there they are. But we don't want to wait that long. We want right now to be repainted, so we call repaint. Method we inherited, and it says repaint me, please. Neat. Now, what are oval, rectangle, and line? Where'd they come from? Yeah?
Come from the graphics class?
That's a good guess. Maybe there's a graphics package, and this is where they came from. But that's not where they came from. Yeah?
Did you create?
I created them. They're just down here somewhere. Here's the oval class. It has these instance variables. It has a center, a radius, and a color. And it knows how to draw an oval. You give it a graphics context, it'll draw an oval in it. There's a rectangle class. It knows how to paint itself. And the line class, it knows how to paint itself. So I just created these 3 helper classes so that I had a place to store them. All right? So what are you going to expect to see when we look at the paint component method? What's going to be different about it than about past paint component methods? You've seen what it does. What do you think the code's going to look like? Yeah?
We'll have private variables for the arrays that contain the ovals, rectangles.
Well, those are right here. So the paint panel already has control of these 3 lists. So what does paint component have to do? I know a lot of you know, you just don't want to say. Someone be brave and say it. What's paint component going to do with those lists? Yeah?
Call it draw method on each object.
Right. It's going to draw each oval, each rectangle, and each line. So here's the code. Starts out like before. So it has a little loop that looks at every oval, and each oval knows how to draw itself on a graphics context. So it says, okay, oval, paint yourself. Rectangle, paint yourself. Line, paint yourself. Yeah?
Could you have oval, rectangle, and line be implementing something like a shape object, and then just have
Yep, you're way ahead of him. He's looking forward to the next example. What happens if I comment out r.paint? How will that affect my applications? The last thing I'm going to ask you. Yeah?
The rectangles won't be there.
Rectangles will never show up because we never draw them. We're creating them, add them to a list, but they're never actually drawn. So yeah, it'll put these guys down, and if I put line, it'll draw them. But rectangle, they're being created, they're added to the list, but we're never painting them because we commented out the code that would paint them. All right. So there we are. We're at the 3rd package. So there's still paint 4 through paint 7 to look at. So next time we'll again, our goal is to see how polymorphism is being used. We'll pick up here next time.